Hello and good day. Today we are going to tackle on exact ODEs and integrating factors. Last time, the very first thing that we need to do if we want to solve differential equations is we want to see if it's variable separable or kung pwede na ba ma-algebraically distribute ang mga variables from one side of the equal sign to the other such that if ma-separate na itong mga variables, dali lang siya dahil ma-integrate. No? If dili siya directly separable, maybe we could introduce another variable u and substitute it to the y's. Okay? So what if dili pag yun, no? Dili siya easily variable separable and dili po siya homogeneous equation. What will we do next? For this recorded lecture, makabalo taon sa pag-determine if ang isa ka given equation is an exact ODE. Okay? So, move on to the next slide. Before we'd actually know what exact ODEs are, let's have a brief review on some topics that you've had in your differential calculus, particularly on partial derivatives and partial differentiation. So we are given an equation, function u, in terms of x and y. Okay? And then equation 2, the derivative or the total derivative of this equation u is equal to the sum of the partial derivative of this equation u with respect to x and the partial derivative of this same equation u with respect to y. So, kung ako ning basahon ning equation number 2, du is equal to partial u with respect to x dx plus partial u with respect to y dy. So, I hope naka-remember taon saon pag partially derive ang isa ka function with respect to x and with respect to y. Let's say, for example, i-derive na tong isa ka equation with respect to x, we hold y constant. Okay? And the same gyapon, if i-derive na to with respect to y, we will hold x constant. And duha man to ka separate equations, ato tong i-add, no? I-add lang. Mo to siya ang total derivative of function u. This function u may be equal to an arbitrary constant c, such that if i-derive na to ang function u, and i-derive na to ang constant c, the derivative of function u, which is du, would then be equal to 0. So if combining, pwede na to ma-combine ang equation 2 and equation 4. Thus, partial u dx plus partial u dy would be equal to 0. So let's look at this given example. Function u, in terms of x and y, u is equal to x plus x squared, y cubed is equal to c. This c could be any arbitrary value. If I derive natin ni partially, du is equal to 1 plus 2xy cubed dx plus 3x squared y squared dy is equal to 0. So, rearranging the variables into a form that is explicit in nature, y prime is equal to dy over dx is equal to negative 1 plus 2xy cubed all over 3x squared y squared. Maybe I'll upload a separate recitation video kung how to solve this one, no? At least ma-review sa kung saan pag partially derive ang isa ka function with respect to x and with respect to y. So, now, ang atong nabuhat na buhat lang karon is atong na-solve ang derivative of u. Okay? So, ODEs then of this form can be solved by going backwards. So, ang ordinary differential equation is kanang atong answer, no? What we will do is we just reverse the operation that we did on how to solve this, the derivative of u. Okay? So, on how to do that, maybe it will be much clearer kung mo refer ta sa another video na kung i-upload together with this one. What then are exact ODEs? Okay? So, katong sa previous slide, ang final answer ato, that's an example of an exact ordinary differential equation. That's why to solve the exact ordinary differential equation, we go to backward to come up with the original function, which is the solution to that differential equation. A first order ODE then is having this form. A function with of x and y, a function m of x and y plus another function m with respect to x and y, y prime is equal to 0. So, i-replace na to si y prime og dy over dx such that mas siya tanaon kaninga form. First highlighted equation, let's say that will be our equation number 1 for this slide. mxy dx plus nxy dy is equal to 0. That is the form, or muna siyang standard form of our exact ODE. Now, not all ODEs of this form are really exact. No? How do we know if ordinary differential equations of this form, equation 1, are exact ODEs? So, we perform a test of exactness. That would be equation 2. The partial derivative of m, kanang mxy lang ha, dili tanan, but the partial derivative of m with respect to y would be equal to the partial derivative of m with respect to x. So, i-derive na tong m with respect to y only, and we derive n with respect to x only. If mo equal gan sila, we can conclude that that ODE is an exact ordinary differential equation. The next step would be inspecting asa sa duha, m or n, ang less complex tanawon. So, if mas simpler looking si m, we'll use u is equal to the integral of m dx plus a function k with in terms of y. Pero if less complex tanawon si n, we'll use the second equation, u is equal to the integral of n dy plus a function L in terms of x. Actually, muna ni ang answer, no? This is the solution to our differential equation, u. Yet, pangitaonon pa nato either si k of y or L of x. So, how do we do that? I-derive na po nato si u with respect to either x or y, depende kung asa atong gigamit originally before, si m ba or si n. If si m atong gigamit, partial derivative na to si u with respect to y. No? Gamito na to ning equation b. Pero if gigamit na to si n ganina, gi-integrate na to si n, ang pag-partial derive na to sa u will be with respect to x. So, if medyo cloudy pa siya today, mas maklaro na later kung at mag-solve na tag sa mga examples. Okay, ato lang timanan ha. If ganina napilian na to, no, napilian na to si m kay mas less complex looking si m, atong i-equate ang partial derivative sa u kay n. Okay, so medyo opposite atong panggamiton nga equations. So, how to do that? Actually, after ato na solve na rin nato ang differential equations. Okay? Now, how to do all those things, to do all those process, let's try to solve these examples. So, ang mga solution and answers to these examples kaning tulo ka buok, akong i-attach to a separate recitation video. Okay? As before, sa separable ODEs, What if dili siya directly separable? So we use y is equal to ux to transform that homogeneous equation to a directly variable separable one. Same here. What if dili siya exact ODE? No? Now, there are times dili naman nato na ma-solve. Pero what if pwede pa nato dahil siya ma-transform from an inexact ODE to an exact ODE? So how do we do that? We introduce an integrating factor. What if the DE is inexact? We find an integrating factor, a function I in terms of x and y, and multiply it to the original function to make it exact. So, inga na lang. Pangitao na, magmangita tag isa ka function in terms of x and y, i-multiply sa original equation, na ano dahin tay exact ODE. And we'll perform the same process as we did from the earlier slide. So where can we find this this I? I mean, where can we find this integrating factor? So we perform yet two tests again. If 1 over n times the difference of partial of m and n would be equal to a function g of x, a function of x alone, then we use the first equation for y. If dili gani, if 1 over m times the difference of partial of m minus partial of n, and ang answer is a function x with respect to y and a function of y alone, we'll use the second formula for I. Okay, that's the only time na gamito nato ning mga formulas kung masatisfy ang condition. So if dili gani ni masatisfy nga condition, then the function may not be solvable using integrating factors, nor is it an exact nga ordinary differential equation. There may be other ways to solve it, but most definitely dili siya through integrating factor or through exact ODEs. So to make these things more clearer, let's try to solve again these examples. No? So kaning example, I will not necessarily solve the ODE. We will just have to determine the integrating factor nga i-multiply sa ODE. Okay? So, again, akong i-attach sa separate video ang solution to finding the integrating factor of these examples.